Welcome back. So in this video lecture we will try to determine the electric field and force experienced due to continuous charge distributions. Okay. So if you carefully see, the question states that there is a finite sheet which is extended in x plane and y plane with the constant z is equal to 0 plane, and it has a charge density. This is a charge density. This is a surface charge density. So now surface charge densities are represented using the symbol sigma, but in some textbooks you can write it as rho s, okay, which indicates it is charge density, surface charge density. Okay, find the total charge on the sheet at one particular point. Okay, so now we will go step by step. First of all, we will determine the charge due to this continuous charge distribution, surface charge density. Now we will the first thing, see, I will concentrate now only on the total charge on the sheet. So the first question is total charge on the sheet. This may be a little bit confusing one, so I wish all of you to pay attention on how it is being determined. Okay, so now if you carefully see, the sheet is a surface one which dimensions with the dimensions of x and y, which are varying with the constant z value. So which means that the surface which I am going to consider, I'll take it as consider system, Cartesian coordinate system, where ds surface, because it must be extending in two dimensions. So here I do have in Cartesian system, I do have x, y and z. So now which is varying actually, z is constant, x and y are varying. So I'll consider as dx into dy. This is my surface area, differential surface area, where dx and dy, these are the differentials in x and y directions. Now, if I want to determine the q, then when a surface charge is given for me, I do have different formulas for q, right? When a line charge is given for me, I am supposed to integrate it over the line. So it can be written as rho L into dl, or sometimes it will be written as lambda, right? Lambda into dl. Or if I do have a surface charge, sigma ds. Sometimes it is written as rho s into ds, rho v dv. Okay, so now if you carefully see, q, I have got surface charge, so I am supposed to employ this particular formula. I am supposed to integrate it over the entire surface, rho s ds, or I can call it as sigma also. Now rho s has already been given for me. This is the equation for my rho s. So I'll take this one, rho s over the surface. Its value is xy into x square plus y square plus z square whole to the power of 3 by 2 into ds. Into there is nano coulombs, right? So I am supposed to use 10 to the power of minus 9 here. Okay. Now this surface, now it is extendable in both x and y. So I'll separate the integration. X is equal to 0 to 1 and y is equal to 0 to 1. So this is xy, x square plus y square plus z square whole to the power of 3 by 2 into, now this I am writing as dx into dy into 10 to the power of minus 9. So this is my charge, how I am supposed to evaluate this one. Okay, so now if you carefully see, I am supposed to first integrate this equation with respect to x, and then I will differentiate it with respect to y. So when I am doing it with respect to x, so I will separate this y because it has nothing to do here. So y, where y varies from 0 to 1. So I will integrate x here. So first of all, I will do this one. Next I will do this entire thing. So first of all, I am doing this, the one which is present in this brackets. I am differentiating with respect to x. Now if you carefully see here I have got x and dx. Here there is a quadratic term. Rather than going with the uv, integral of uv rule, I have a small plan here. So in this equation, okay, I am considering only this particular equation. Okay, I will do it separately for you. Now, what is my expression there? Integral of x into x square plus y square plus 25 whole to the power of 3 by 2 dx, right? This is my integration which I am supposed to do. So in this one, what I will do is let x square be some t. So what I will get? 2 dx is equal to, right, this one. So wherever, sorry, this is 2x, right? 2x dx is equal to dt. So what is x dx? It is dt by 2. So I am substituting this one here. Instead of x dx, what I will write it as dt by 2. So I'll write it as 1 by 2 integral t plus y square plus 25 whole to the power of into dt. Okay. So now this one, this is a constant because I am going to differentiate it only with respect to t, right? So this will just be just like a constant, some k, right? So now t plus k whole to the power of 3 by 2. This is also a constant. So I have nothing to do with this one. So it is just like some single power expression where t plus k whole to the power of 3 by 2. So what I will get here? I will get t plus y square plus 25. Okay. This will be written 5 by 2 by 5 by 2. Isn't it? So because x power 3 by 2, what is the integral for this one? It is x power 5 by 2 by 5 by 2, right? It is very similar to integral of x power n, where it is x power n plus 1 by n plus 1. The same I have applied. So this is my expression. So what I will bring here? It is 1 by 5. So now I will again replace this t with x square plus y square plus 25 whole to the power of 5 by 2. This is my expression now. This is, now if I apply it for x is equal to 0, so what I am supposed to do? I am supposed to apply this one, x square plus y square plus 25 to the power of 5 by 2 on x is equal to 0 to x is equal to 1, right? So if I substitute x is equal to 1, what I will get? If I substitute x is equal to 1, what I will get? Here this will become 1. This is y square plus 25 plus 1. It is y square plus 25 whole to the power of 5 by 2. X is equal to 0. This will become 0. So you will get y square plus 25 whole to the power of 5 by 2. This is the answer. See, this is 26. Okay, this is 26. So this is the expression. So I have simplified this one using. So now if you carefully see in the previous, see this entire expression now from x is equal to 0. Now it has been simplified for you. Now I will employ this one. So now what is q? So now if I consider this equation now, this is q is equal to integral y is equal to 0 to 1 y. So what we have obtained in the previous slide, yeah. So this is the equation, right? So this is the equation now. If you carefully see, again I can make it as 1 by 5. I'll separate this one, y into y square plus 26 whole to the power of y by 2 minus y square plus 25 whole to the power of y by 2, sorry 5 by 2 into dy. Again what I will do, I'll take y square as t. So what I'll get, 2y dy is equal to dt. So y dy is equal to dt by 2. So again I'll try the same what we have done yesterday, what we have done in the previous slide. So again y dy will be taken as dt by 2. So I'll get here 1 by 10 integral y is equal to 0 to 1. So this one will become t plus 26 whole to the power of 5 by 2 minus t plus 25 whole to the power of 5 by 2. This is dt. So the 2 I have written here, 5 into 2 is 10. So now see the integration here. Now what I will get, this is t plus 26. What I'll get, 7 by 2 by 7 by 2, right? Minus t plus 25. This is again 7 by 2 by 7 by 2. Right. So what is t? T is actually y square, right? So I will replace it this one. So what it is 1. I'll take 7 by 2 common and I will multiply it here. What I'll get 35 here, 1 by 35. So it is y square plus 26 whole to the power of 7 by 2 minus y square plus 25 7 by 2, where y varies from 0 to 1. So this is the value of q now. So now compute this one. So yeah, what is y? Y is equal to, q is equal to 1 by 35. So this is y square plus 26 whole to the power of 7 by 2 minus y square plus 25 whole to the power of 7 by 2 at y is equal to 0 to y is equal to 1. So what I can write this one as, if y is equal to 1, then this will become 27. 27 to the power of 7 by 2 minus this will become 26 to the power of 7 by 2 minus, where y is equal to 0, this will be 26 to the power of 7 by 2 minus this is 25 to the power of 7 by 2. So what I will get here, this is 1 by 35. This is 27 to the power of 7 by 2 minus 25 to the power of, sorry, I think minus into minus it will become plus. Right. Isn't it? So this is into 10 to the power of minus 9, which I already have. So I can show you in the previous slides that there was 10 to the power of minus 9 here. Yeah. See, this was 10 to the power of minus 9, which I have replaced now. 10 to the power of minus 9. So this is the final answer for this one, and you will get somewhere around, this value is 33 somewhere around. So 33, this can be represented as nano, and this is coulombs. So this is Q is nano coulombs. Okay, this is the way how we compute the charge on this sheet. Now in the next video lecture we will try to compute the electric field at this particular point. Okay, that's it for today.